Okay, so question 11, okay, states is the following. It said r plus 1 by 2 to the power of r. That's the Tn term. Tn is r plus 1 by 2 to the r. The Sn term, or the sum of all the series, is n into 2n plus 1. So, what we have on the left side is the sum starting off from r equals 1. So that's basically t1 plus t2 plus t3. And that's all on the left hand side. Okay, so that's all the way up to Tn. Okay, that's what this represents here. Okay, and each term is represented by the formula Tn. Okay, so with this in mind, if I wanted to find out what Tk is, Tk would be k plus 1 to the power k, and in fairness Tn would be replacing the r with n as well, so it would be n plus 1 to the power of n, and then t of k plus 1 would be replaced k with k plus 1, that ends up be k plus 2 into 2 into k plus 1. Okay, so we can see a couple of things here. Now, step 1 on this proof is to test p of 1. So test p of 1. Okay, so what you want to find out here is that we want to find out what T1 is. So LHS is equal to T1, because it will be T1 on the left, and that's going to equal 1 plus 1 by 2 to the power of 1. And what we get here is the LHS equals 4. Now the RHS, this formula here, is replace n with 1. We're going to get 1 multiplied by 2 into 1 plus 1, once again equals 4. LHS equals RHS. So what we have here is true for p of 1. That's step 1. Now that we're done with step 1, we're going to go on to step 2. Step 2 is to assume true for p of k. So step 2, assume true for p of k. For p of k, such that the sum of k terms, so you're replacing n with k, remember n gets replaced with k, so still is r equals 1, and still r plus 1 by 2 to the power of r equals k into 2k plus 1. Now remember that this here represents t1 plus t2 plus dot 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 all the way up to tk. Now what we're going to do next is we're going to test for p of k plus 1. Now p of k plus 1, replace k with k plus 1, so it's going to be k plus 1, r still stays the same, r plus 1 to the power of 2r still remains the same, and that will equal k plus 1 into sorry guys, at the start is n plus 1, and this tk here would have been k plus 2, because it's n plus 1. Oh yeah. Sorry, excuse me guys, it's back the way it was. Okay, that was t of k. So what we have here is we need to find out what s of k plus 1 is. So we're going to replace the k with k plus 1 over here. So we're going to end up with k plus 1 bracket 2k plus 2 close bracket. Now this here represents t1 plus t2 plus dot 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 plus tk plus tk plus 1. So what we can plug in here is what tk was. Remember, all the way up to tk equals this value here. So it's going to be k times 2k plus 1. Now we have to find out what t of k plus 1 is. Well, we found that out earlier using this general formula here. So t of k plus 1 is k plus 2 bracket 2 into k plus 1. K plus 2 in brackets 2k plus 1. And this all has to be equal to this value here. K plus 1 into 2k plus 2. Now, okay, so we're just going to multiply this out. So we're going to multiply this part out here. So we're going to get a k by 2k plus 1 plus 2 multiplied by 2 into k plus 1 all over k into 2k plus 1. You can see these guys are the same. So that's going to be 2k into 2k plus 1. And this here is going to be add the power of indices. We're going to get 2 to the power of k plus 2. Now, look at this again. We can multiply the 2 to the power 1 by the 2 here. So we're going to add the indices again. So we're going to get k times 2k plus 2 plus 2k plus 2. Factorize out k. Factorize out 2k to the power 2. And we're going to end up with a k plus 1. And then that equals k plus 1 by 2k plus 2. LHS equals RHS. So therefore, so what we have next is P of k. P of k plus 1 is true if P of k is true. If P of k is true, hence P of n is true. By the principle of mathematical induction. Okay, so that's that question done. Now, in question 12, what we have is in question 12 we have hints here. Okay, so what does 5 factorial mean? 5 factorial means 5 by 4 by 3 by 2 by 1. 4 factorial equals 4 by 3 by 2 by 1. So you can see the difference between 5 factorial and 4 factorial is the presence of the 5. Therefore 5 factorial equals 5 multiplied by 4 factorial. This sequence works out the same for 10. 10 factorial equals 10 multiplied by 9 factorial. K factorial will equal k multiplied by k minus 1 factorial. K plus 1 factorial will equal k plus 1 multiplied by k factorial. Always a difference of 1 between the numbers. 100 factorial will equal 100 multiplied by 99 factorial. Okay, so that's how this works. Now, we got a sequence for P of n, this one here. 1 multiplied by 1 factorial, 2 multiplied by 2 factorial, 3 multiplied by plus 3 multiplied by 3 factorial, plus n multiplied by n factorial is equal to n plus 1 factorial minus 1 for all n elements n. So we're going to obviously do what we normally do, test for test P of 1. Now, when we test P of 1, the left hand side is represented, we're going to use T1 only. Left hand side equals T1, which is equal 1 by 1 factorial, which equals 1. The RHS equals S1, because this represents Sn, the sum of all the terms. Okay, and that's going to equal n plus 1 factorial. So n this time is 1. So it basically means n equals 1 for this one. So it's going to be 1 plus 1 factorial minus 1. 2 factorial minus 1. 2 factorial is 2 minus 1 equals 1. LHS equals RHS, true for P of 1. Okay, so what we have after that is going to be part 2. Assume true for P of k. So when I assume true for P of k, it's going to be 1 multiplied by 1 factorial plus 2 multiplied by 2 factorial plus dot 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 k multiplied by k factorial. Now part 3 is test for P of k plus 1. Oh, I also forgot to replace in k there, so it's going to be k plus 1 factorial minus 1. That's basically S of k. Test P of k plus 1 P of k plus 1. So this time it's going to be 1 multiplied by 1 factorial plus 2 multiplied by 2 factorial plus dot 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 k multiplied by k factorial plus k plus 1 multiplied by k plus 1 factorial. And this is all going to equal, I got to replace this k with k plus 1. So k plus 1 plus 1, k plus 2 factorial minus 1. Now, what we discussed before is that this here is basically t1, t2, all the way up to tk, basically S of k. S of k is k plus 1 factorial minus 1. And that's going to be plus, we have to add in t of k plus 1 at the end, so that's going to be k plus 1 multiplied by k plus 1 factorial. Now, this one here is S of k plus 1. We're going to turn k plus 2 factorial equals k plus 2 multiplied by k plus 1 factorial. So you're going to change that into k plus 2 multiplied by k plus 1 factorial minus 1. So we're going to multiply this out. So if we factorize out 1, see the way that's k plus 1 and that's 1. Take out k plus 1 factorial. And what you're going to be left with is 1, and then it's going to be plus k plus 1. This minus 1 stays at the end, and then you're going to get k plus 1 factorial multiplied by k plus 2. Same thing as k plus 2 multiplied by k plus 1 factorial minus 1. And that has to equal the right hand side of k plus 1, k plus 2 factorial, k plus 1 factorial minus 1. LHS equals RHS. So therefore, P of k plus 1 if P of k is true, hence, by the principle of mathematical induction, P of n is true. Okay, so that is questions 11 and 12.